Hello, I'm Otavio Oliveira, student of last year of Mechatronic Engineering at Facens, Brazil. In this video, I will present the project I developed for GSoC 2020, Arduino controller for liquid galaxy. But what is this? Arduino controller is an embedded technology device that allows free navigation on liquid galaxy. This device has specific navigation functions, such as moving the camera or point or view in available directions using a joystick. You can zoom in or zoom out on the display with a simple movement of the user hands using its ultrasonic sensor. It allows direct navigation to 16 predefined points, which can also be customized by the user using a matrix keyboard or through the pre-programmed voice commands and its built-in voice recognition module. The controller also has 3 buttons. Change the voice commands groups. The second button is used to make a tour among the 16 available places. The third button performs an orbit around the visited point. The second embedded device developed is a controller glove that allows navigation similar to that of the controller joystick. Wherever this navigation is done only with movements of the user hands. The movements are read by an accelerometer sensor and converted to navigation commands. The glove has 5 buttons for performing a tour among the 16 available places, change the navigation commands like zoom, tilt, roll, and other camera movements, perform an orbit around the visited point, navigate one place at a time advancing in the list, navigate one place at a time going backwards in the list. Technologies used. For the complete development of this project, different technologies are used. They are hardware, ESP32 microcontroller for data process and control, analog joystick for navigation control and camera movement, ultrasonic sensor to change the zoom, 16K matrix keyboard for direct navigation to predefined places, voice module for direct navigation to predefined places using voice commands, conventional push buttons for tour, orbit, and the exchange of voice commands, accelerometer sensor for navigation, control, and camera movements, and LEDs for visual identification of the commands. Software. This project has a second stage of development, where an Android application for a smartphone was developed using the Android Studio program interface with SDK Dart and Flutter framework. The developed application has a simple interface and allows the user to change the ride time during the tour, allows the user to insert or change Wi-Fi connections data dynamically when using the controller or the controller glove, allows the user to update the navigation list dynamically while using the control devices, using the available navigation examples, or create a personality list. The creation of the personalized list is simple and intuitive. It is enough for the user to create a new list and insert the 16 navigation points desired, informing the coordinates and the range of view. The second piece of software developed is two Python scripts responsible to receiving data from controllers and executing the related commands in the Liquid Galaxy. Development and learning process. During the development of this project, I was able to expand my knowledge on different points, such as know the Liquid Galaxy environment and the technologies related to develop of applications for this environment. During the communication process with the Liquid Galaxy community, before the announcement of my participation in GSoC, I started studying the technologies used in the old projects developed in previous editions of GSoCs. I installed my version of Liquid Galaxy, initially using virtual machines with VirtualBox, another technology I didn't know until that moment, and later migrating to the use of common computers with Linux operating system and Ubuntu 16.04. During this period of study, I tried to know how the system works and what were the ways of communication with external devices. I tried to run some projects for previously editions of GSoC, and finally, upon receiving my approval, I started to work definitively with the execution of my project. As my area of study is not 100% focused on programming, knowing these new technologies was a great challenge and at the same time a great learning experience. Python scripts development. Before starting this project, I didn't know the Python programming languages, and I had to research a lot about it. To develop a clean and a functional project, I did several tests and sought help with my friends to finalize my script, which, despite being simple, it cost me a few hours of study. Another great challenge was the creation of a complete Android app, fully developed in Flutter. Before carrying out this project, I had never developed an Android application with a professional development environment, like an Android Studio, so that I could take the project forward and deliver a complete and functional mobile application. I need to study this programming language a lot, looking for details of use in the official documentation and reserving a few hours of a daily study for interpretation and application of the commands and libraries necessary for my project. I was also able to develop my knowledge of the ESP32 microcontroller, taking a few hours to read and interpret the datasheet, and also with practical learning and solving problems encountered during the assemble and program process of this microcontroller. Finally, the integration with other project participants who helped me with development and in this learning process. Also, the collaboration of students of the Liquid Galaxy Lab in Spain, which allowed a great immersion in other languages and also mutual learning during the weekly follow-up meetings. Without a double This challenge provides great learning and technical development during the 3 months of work at GSoC 2020. Demonstration of control operation with the help of Josep Cunhat Porta at Liquid Galaxy Spain. Navigation example using the matrix keyboard, pressing the 1 key. Now pressing the key 2. Pressing key 9. Pressing the 5 key. Testing joystick movement. Change the joystick navigation. Tilt the camera. Moving the camera horizontally. Testing zoom with ultrasonic sensor. Pressing another key on the keyboard. Testing the ultrasonic sensor again. Starting the tour. By default, the tour time is 10 seconds. Controller model reproduced by students of Liquid Galaxy Lab, Spain. Demonstration of navigation of voice commands. 1. 2. 3. 4. The voice model has a limitation. It doesn't allow loading the recognition buffer with all commands. For this reason, it is necessary to switch between groups of voice commands. 5. The red button on the controller changes the command group, and the green LED indicates the group number by flashing the corresponding value. 9. When the LED flashes 4 times, it is indicated that the recognition buffer is in position 4. 15. 15. The yellow button makes an orbit at the place visited. Initially tilts the camera by 45 degrees and then starts the orbit. This orbit usually takes a few seconds. The control gloves allows you to navigate the liquid galaxy just by moving your hand. Its accelerometer sensor reads these movements and converts them into control commands for the liquid galaxy. Pressing the button located on the palm of the hand, it is possible to change the navigation mode. Its operation is similar to that of the joystick of the first controller. Alternating between the three forms of navigation available, it is possible to perform the following movements: camera up, camera down, left, right, horizontally, tilt, roll, and zoom in and zoom out. Pressing the button located at the top of the device, it is possible to start a tour of 16 places. To stop the tour, just press the button again. With the two navigation buttons, it is possible to move forward and back in the list of places. And lastly, pressing the orbit button will start an orbit at the visited site, which can be interrupted if you press the orbit button again. To facilitate the use of the controllers and allow the user to modify the navigation locations, an Android application was developed that allows a Bluetooth connection to the controllers so that the travel coordinates and other information are updated dynamically and without the need to disconnect the controller to reprogram it. To change the navigation location, the user needs to open the application, click on the Examples tab in the menu, and choose one of the available examples. After choosing the list, the user needs to click on Save to Send, connect it to the LG controller, and send the data to the controller. When, just continue browsing freely. The available examples are green, soccer stadiums from different continents, blue, racing tracks from different continents, and red, standard navigation list with some famous touristic chicks from the world. The application also has a page where the user can create their own navigation routes. By default, the tour time is 10 seconds, but this time can also be changed using the app. The user needs to open the application, click on Tour Time tab, enter the desired time, connect to the Liquid Galaxy controller, and send the data. In order for the process to be completed, it is necessary to stop the tour that is taking place and start it again by clicking on the tour button. Now the tour time is updated. The controller and the glove can be used without connecting cables, using a Wi-Fi connection and batteries. To connect to Liquid Galaxy, you need to start the Python script on the master computer. Then, open the Android application, click on the Network Info tab, enter the IP of the master computer and the data of network to which it is connected, SSID and password. After connecting to the controller and send the data, in some cases it may be necessary to perform this procedure twice. The connection confirmation is made with the LED off. After the LED stops flashing, the control is ready to be used. The application works integrally for both controllers. Both have a Bluetooth connection to receive user updates. In order for the controls to work correctly using Wi-Fi connection, it is necessary to allow their connection on the main computer's firewall, as the device makes a connection via SOC through port 8000. One. Three.